Welcome everybody to my new work for this course. The question today is what's the mass of the black hole? What hole? But what black hole? This. We can see a star, the red ball, moving around a blue ball. The blue ball is the black hole. The green curve is the trajectory of the star. To solve this, we need to use the momentum. The momentum is a vectorial magnitude equal the mass of the object times its velocity. And the momentum has the same direction as the velocity. According to the Newton's second law, the net force is equal delta P divided delta T. So, if delta P divided delta T is not zero, then there must be a force because net force is not equal zero. The chain of the momentum has the same direction as the net force, as we can see in this example. We assume there is only one force, gravity iteration. So, according to Newton, the gravity iteration is equal capital G, the universal constant of the gravitation, capital M, the mass of the black hole in this case, the mass of the star, and R is the distance, so divided by distance square. We'll do this. We have the position. With the position we can calculate the velocity for every point of the trajectory. With the velocity we'll have the momentum, and then we'll have the chain of the momentum, also the net force. With the net force is equal the gravity iteration, we can easily calculate the mass of the black hole. In the program we have to fix the initial condition, like the size of the star of the trail, the mass of the star, or the value of capital G. With the position, we'll calculate the velocity like this, and then we can calculate the initial velocity and final velocity, and the momentum initial and final, and the chain of the momentum divided by delta T. So the net force and two components of the net force, the parallel net force and the perpendicular net force. We're going to draw this vector, net force and perpendicular and parallel net force, with these arrows. And so we can see the situation. The star is the red ball, and the white arrow is the net force, the blue arrow is the perpendicular net force, and yellow arrow is the parallel net force. Here we can see the mass of the black hole. We can imagine what would happen if the mass of the black hole was higher. If the mass of the black hole was higher, the gravity iteration would be higher, and the chain of the momentum would be higher. So the trajectory will change. Something like this. Brush.